Okay, so around 1995, Amazon system was primarily based on links and lists. So if you showed up at Amazon, it looked like this. Let's see if this link is still active here. There we go. This is what it looked like. So they had a little title screen here, and I remember this page from back in the day. This is what I was used to seeing. So down below, you can see a million titles. They have a million title catalog, and you can look at recommender lists for 20 categories. They had customer reviews. They had lists of award winners of various ones, and some bestsellers. So they had links and lists. That's how they got to the recommended content. Now, the way they generated a lot of these links, aside from the obvious ones like who are the current bestsellers, they had recommendations from people inside the organization. So like Joe, they'd ask Joe, hey, what are some good books you've read lately, Joe? And he'd make up a list. And then they'd ask Susie, hey, Susie, what are some of your favorites in this category? And she'd write up a list. And that's what they did. So it was not the big real-time recommender system we have now. Okay, so their core process flow, what would happen? Customer visits the website, orders the books, Amazon contacts the publisher, gets it together, brings all the books together, packages them, ships them out. So we can draw this in Paint as far as their basic structure. All right, so here's Amazon in the middle, right? And we can have a bunch of customers on one side. Okay. And then this part I'm just going to flip around because we can do that. Okay, so this part, let's select. Well, we need to back that up a little bit, don't we? Well, we're not going to do that. We're going to stretch this out. Okay. We'll make this work. Don't worry. Hang in there. There we go. Okay. So this we're going to take and flip around. Okay. So we have publishers on this side, Amazon in the middle, and then customers on this side. Okay, and everybody can see how that works. So customers send orders, Amazon sends orders to publishers. Okay, and then Amazon publishers send books to Amazon, and then Amazon sends books to customers. Okay, so pretty easy to understand how it all works. Now, value chain components. Well, we talked about primary activities, we talked about secondary activities. So remember, primary activities are the ones that are a direct part of fulfilling orders, essentially, and they're going to directly add value. And in general, they're easy to measure. They're easily quantified. So, for example, operating the website. Amazon knows how much it costs to host the website, knows how much they're paying for hardware, all that, knows how much they're paying for the people who write the code that runs on the website, all of that. Okay, so they know how much it costs to run their website. So that's easy to measure, and it's a necessary part of their operation. Number two, acquiring titles, right? Their procurement, essentially. They buy books from the publishers, and then they sell them on to the customers. So Amazon knows how much it costs to buy a title from the publisher, and they know how much they're selling it for. So that's, again, easy to measure and an essential part of the order process. Packaging and shipping, right? Amazon knows how much all that costs. It knows that if it's charging $5 for shipping, but it only costs Amazon $4 to do it, they're making a little bit of money there. On the other hand, you also have secondary or supporting activities. These are ones that indirectly add value and tend to be quite difficult to quantify. So examples there, human resources, right? Hiring the best people. Sure, you want to hire good people, but it's hard to know when to stop, right? Obviously, you're going to want to spend some non-zero dollar amount on interviewing and otherwise selecting potential employees, but there's no guarantee that more money into that is going to give you a good return. Same thing for customer support, right? If you have zero customer support, that can't be good. but there's going to be an upper bound on how much customer support is cost effective. Okay. Now, let's talk about how this recommender system impacts the value chain. Well, early on, right, Amazon's system, I'm going to just shrink this a bit. So I have room for, oops, I have room for other things. I'm going to shrink you down. Boom. There it is. You know what? Let's move over off to the side too. Wonderful. There we go. Okay. So we'll make some notes over here on the side. Initial recommender system, I'm just going to call it RS because that's shorter, based on static lists. Okay. Either read from public data, right? So things like New York Times bestseller list, for example, or from employee opinions, right? 20 books that Joe likes. Now, subsequent recommender system, right? The advanced recommender system, people who bought this also bought that, right? That's the recommender system that we know. You go to Amazon, you look at a product, and for any product you care to look at, it'll show, you know, similar products. Or also people who looked at this also looked at that, which can be a very useful bit for, say, new products or products that otherwise do not have a lot of purchase history. Okay, if it's something that Amazon just started carrying, for example. So that's the recommender system. So what does Amazon have to put in to make this all work? How does Amazon integrate this recommender system into their existing processes, and what changes? Well, some key things that change. Number one, what's the point of the recommender system? Why does Amazon want to do this? Why is Amazon even bothering with a recommender system? It sounds like a lot of work. What's the goal there? Go ahead, shout it out. Impress me with your knowledge. Hello?
You said what's the goal of the recommending system?
Yeah, why is Amazon even doing it? What do they hope to achieve?
Um, more business, more sales.
More business. Well, let's be specific. What do we mean by more business? I mean, we're going to say it's going to be good for their business, but what specifically do they hope to see?
More profits.
More profits. Why are they going to get more profits?
Well, if
Not
they
saying you're wrong. They want more profits. What?
are showing different items that they recommend, that means it's just like advertising like on their own website, so it can draw in more things or more sales, because people will look at that and be like, oh, maybe I actually want that, and then they'll get it.
Sure. They hope to boost their sales and boost their profits, right? In a sense, once they get a customer to their site, you know, the customer is interested enough to buy something, so they're hoping, first of all, yeah, we see a note here. That again, that is largely true, right? The core idea there is correct. Once somebody comes to their site, they're interested in buying something. Amazon says, okay, you're buying some things, you're looking at these things. Here's some things you might be interested in. But the other part of it that's a bit more subtle is that a lot of customers wander into a store with only a vague idea that they want to buy something, right? If any of you have ever been in a physical bookstore, like you're going on a trip or you're looking to buy something for a present for somebody, and like, I want to buy a book, but I don't know exactly what I like, right? But you have a rough idea. Maybe you're buying something for, I don't know, for your cousin, and you know that your cousin likes books on cars. So you look for a book for cars, right? But you don't know exactly what's what, or what is a good book or what's a crap book. You don't know. So this sort of idea that you have undecided customers coming in and you give them some things that you might be interested in this stuff and hopefully help them make better decisions, right? You help them navigate through Amazon's massive, massive, massive list of books. And thus, you know, instead of a customer wandering into the store and wandering away empty-handed and you don't make any money, hopefully you can sell them something. So that's the goal. All right. So how does Amazon integrate this into their existing processes and what changes? Well, first of all, Amazon needs to gather and provide data in real time, right? More or less in real time. So it can't be not just quarterly or annually, right? Basically, if Amazon's recommender system is going to be worth having, yeah, they got to do pretty short interval refreshes on it, short interval updates. So that's part. Number two, Amazon needs to integrate the recommendations into their website, right? Into their web pages. So that's something that needs to happen. Now, follow up on that. If Amazon succeeds in using the recommender system and sales do keep going up, that will create opportunities. We'll go with that. Opportunities for bulk buying from publishers, right? And maybe they can possibly, I'll say probably, at lower rates, okay? And the same for shipping. If Amazon can have, instead of having one book at a time shipped, if they can do a more efficient method of having truckloads of books shipped, they're going to save money that way. So all of this sort of stuff, these are going to affect how Amazon does its business. So once upon a time, there was just a website and the customers showed up and they looked at some lists and Amazon did this. But what's going to happen? Well, number one, you're going to need recommendations, and those are going to be provided by some kind of real-time analysis system. Lots of data, right? This is going to be a big thing. So that's going to have its own box down here. That's a whole system process that generates the recommendations and puts them up on the website. Other stuff, I'm just going to add in some extra lines here, right? More traffic from the publishers, and quite possibly, right, more traffic to the customers as well. So we'll make a note here. More sales can mean, number one, discounts, can mean what? Bulk shipping, can mean if shipments are coming in large quantities, that means you can have trucks arriving every hour. So it might have been once upon a time, to save money, Amazon would order one truckload or partial truckload of books from a publisher, say once a day. And that's going to affect how fast they can deliver the goods, right? So faster delivery. If Amazon is getting a truckload of books every hour or multiple truckloads of books every hour, that's going to mean that Amazon's shipping time, instead of being 3 to 5 days, maybe it's going to be 2 to 3 days. And maybe for some customers, right? Maybe for some customers, they can even do things like same-day delivery. Also, more sales is going to mean more data, right? So we have a few things with that. System growth, it's just going to keep on getting bigger. But number two, more accurate, right? So as Amazon has recommendations based on a small subset of data, sure, they're probably going to be reasonably good. But as Amazon gets more and more data over years and the rate of data accumulation keeps going up, that data itself is going to be more accurate. You're going to get smaller sample errors. So any prediction Amazon makes about people who are interested in this book will be interested in this other book, those recommendations are going to be accurate, okay, more accurate. So there's going to be a lot of changes that happens in Amazon systems. But the big ones, number one, putting the recommendations on the website, and that's going to entail installing and setting up a whole separate system for managing that data. And number two, dealing with even faster growth. Okay, hope all that makes sense. That's that same comment? Yeah. Okay, so that's some key stuff there, right? How does implementing the recommender system impact the value chain? Well, is it going to add some steps? Yeah, it's going to add steps that Amazon's going to have to inject those recommendations into their site. Is it going to remove any steps? Well, not really. Not really. Not anything that's immediately obvious. Is it going to change the value of the steps? Sure. right? So if Amazon, for example, they're charging the same shipping rates, but the costs on shipping go down for Amazon because they can get these shipments done in bulk, well, that's going to change the value of Amazon's packaging, right? If Amazon is able to order books in bulk from the publishers and get bulk purchase discounts, then that's going to change the value of the order fulfillment component. So, and all these secondary functions like supporting data systems, yeah, Amazon's going to have to build in new systems for managing this large scale data. Human resources, well, when Amazon is small enough that they can operate basically on one copy of Excel, they didn't have to worry too much about that. But if you're saying, well, Amazon needs to build its own recommender system, they're going to need some serious IT guys in there to do that. So their HR is going to have to branch out a little bit and become better able to evaluate who's a good employee or not. And of course, business partnerships, right? There's the scope for Amazon to make all sorts of changes in their delivery arrangements. The obvious one being, instead of having one truckload per day, Amazon can try to schedule truckloads, can try to prioritize things. Amazon can say, you know, we have some books that are coming in, you know, for like 1 day delivery. Those need to get delivered really fast. Those get to be, you know, top of the list. But other books, yeah, if the customer has ordered slower delivery, not going to worry too much about that. So the business partnerships may change as well, but the big thing that Amazon's worried about is shipping and then the cost of actually buying the books. Okay, so short answer, there are a lot of changes to the value chain, most of them good, as long as Amazon can manage the scale problem. Okay, this brings us to the concept of business intelligence. So if you were taking the textbook-based version of this course, you would have a whole chapter where you talk about what business intelligence is and who business intelligence workers are and what they do. But we don't really need to go into all that because business intelligence is a really, really broad concept, but basically means analytics. So all the kinds of data that a business comes into contact with needs to be analyzed. Okay, so things like internal data, how employees are doing, which items are selling well or not so well, and external data like how the supply chain is doing, for example, which partners, which product sources are more reliable than others, which delivery truck drivers are more reliable, that sort of thing, which routes are more reliable based on weather or road closures, things like that. Which products are being returned and why? Is it a failure in terms of shipping? Is it a failure in terms of somebody picked out the wrong product and put it in a box? Was it damaged when it arrived from the publisher? Whatever. Okay, so all that kind of data gets analyzed by people inside the business, and that's basically what business intelligence means. Now, Amazon's recommender system fundamentally is a type of business intelligence. But unlike most business intelligence systems, where the data is gathered by the organization and only used within the organization, Amazon is actually making this business intelligence available to the customers themselves so that the customers can make better decisions. And that is a very big deal. That was a very unusual business model circa 1995. Okay, so again, yeah, business intelligence normally kept internal and the reports get distributed whenever people need them. So, for example, the way a normal supermarket might use this kind of business intelligence. So a supermarket knows that certain products are often bought together. They have an idea of what products are going to sell well based on the current prices and promotions, stuff like that. What these businesses often did is basically tried to inconvenience customers. Okay, so it sounds crazy the first time you hear it because you would think, wow, these stores, they all want to make a shopping experience good for the customers. Well, in fact, it's not that simple. What often happens, supermarkets, they know people need to buy groceries, people need to buy food, and so they know that they're going to go to one supermarket or another, right? There's not a whole lot of choice there. They know customers are coming to supermarkets. So based on that, most of businesses try to some extent to keep customers in the store as long as possible. So items that are high profit, for example, they don't put them on narrow shelves. They put them in spacious areas where customers tend to wander around and get kind of hypnotized by the store. Other things that stores often do. So products that are low cost, low profit margin, or otherwise the store isn't really heavily interested in promoting them, they're going to be put on shelves that are high or low, right? The ones that stores really want you to buy because they're high profit margin, they put right at eye level or, you know, within easy reach because they know that's what customers are going to go for. So stuff like that, that's what stores do. They set out the layout of their store in a sense to encourage customers to stay in the store longer, hoping they'll get hungry, they'll buy more while they're there, and they'll buy the higher profit margin items. Well, Amazon kind of flipped that around. I mean, sure, they want customers to buy higher profit margin items too, but basically Amazon is trying to help customers find what they want quicker and easier. And the fact that so many physical stores were designing their store layouts to keep customers in there longer really just was an extra advantage for Amazon. They knew that customers would keep coming back because shopping was so much easier than it was in physical stores once people had gotten used to the idea of shopping online. Okay, so let's talk a little bit about recommender systems generally. Okay, so how does this all work? So we have our recommender system. Recommender system structure. So the first thing, this is our recommender system. What goes in? Well, basically two things. Three things if you like. So the first one is page views, right? Who looked at which products? Number two, purchase data, okay? And what else? So we'll say purchase data, we'll say correlations. And here we'll say just page view correlations. Okay, so if you want to do that as two things, just pages and purchase data, that's fine. But we're breaking it up into all these things. So Amazon has this complete list of who all looked at what pages. We also have data about which page views are correlated together and which purchases are correlated. Now all this gets ground up together. Data gets analyzed. What are the outputs? Well, right, we basically have our two things. People who bought this also bought that. And people who looked at this also looked at that. Those are the two things we get. And so Amazon, as far as the web page, it implements them basically in two ribbons below the product, right? So we see those in two different screens. If we want to, go to Amazon. Let's see what Amazon's got there today. Whoop. Okay. Let's say we're buying a set, right? Lego, I don't know, Star Wars, sure. Okay. So we got something. I don't know, we'll click on something random. Boom. Ooh, trench run. Okay, now we're talking. So if we look through that, right, we see more to consider from our brands, right? This is, again, basically similar products. Here are ads. Okay, but it's the same kind of thing. More related things, more related ads. Boom. In this case, there we go. Customers who viewed this also bought that. Customers who searched for Legos also bought that. Other stuff. Okay, so I guess I could add, you know, when we do this implementation in a web page, can also consider just similar products, okay, and specifically advertisements by the manufacturer or seller. Okay, so however Amazon does this, basically they have different types of recommendations. Now, strictly speaking, again, these ones are the ones that are all based on internal Amazon data, right? Similar products, Amazon doesn't exactly need this kind of recommender system for that. They can say, oh, there's this family of Lego Star Wars products. We can show some of them. And sure, they'll want to prioritize by how well they're selling and what the profit margin is. Similarly, when Amazon chooses which ads get shown and where, Amazon wants to show ads that have the best chance of getting clicked on. But this is not part of their pure 1995 recommender system structure. Okay? This is just things that are added on now. Now, there are other things, other design questions we might consider. So first of all, historical window length, right? Basically, how far back in time is Amazon going to look when they're compiling this recommendation data? Should they consider data that's 10 years old? Is it relevant or not? Should they limit their data to just the last month or two? Well, the basic problem is this, right? I can draw it out as a graph. Imagine if you have a product, right? So let's say, suppose you're, and let's say we're going to mark this off to, I don't know, 5 years. So years, 1, 2, 3, not exactly drawn to scale, but close enough. Okay, so here's years. And then here is going to be sales. Okay, so if you had a product that was very popular, and do a step graph, it was popular a few years ago, but no longer all that popular. Okay, maybe it looks something like this, and it's been dragging down lately. If your system says, well, we're only going to consider this much of the data, right? If we're only going to consider that, you're going to lose a lot of information, right? On the other hand, if you go with the fat part of their curve, all the fat part of their curve is going to be data that's a few years old. Maybe a lot of products that it would be paired well with now didn't exist back then. So that's one of the basic problems. How far back should your recommender system look? That's problem number one. Okay. Number two, back to our slides, the decay rate. So remember when we talked about Facebook, we talked about people generally want to see more recent posts. Well, same to apply to Amazon. So the next question is, number two, how useful is older data? Or how quickly does its value decay? And I'll add in there, does its predictive value decay? Okay, because what we want from these recommendations, we want them to be good recommendations, and good we assess by the fact that the customer actually acts on them and buys something. So this is something that Amazon can learn for particular products, right? So for some products, maybe the predictive value is going to stay good for a few years. Others, maybe not so much. Maybe it's going to be measured in months or even weeks. Item variety, okay? I'll add that. Avoid circular recommendations, okay? Inject some variety into them. What you don't want to do, right? So for example, if we have a product like this that sold a whole lot a few years ago and is not selling very much now, if we just go on the basis of sales volume, we're not making enough sales going forward that any of this is going to change very much. We're always going to be stuck with the same recommendations. So we're not going to have the chance to learn much about what new products might be properly associated with something. Okay, and this can happen under any sort of curve, right? I mean, we have one here with just old data, but imagine, I'm going to try to clear this out. Let's see if I can pull this off. There we go. Imagine if the product curve is more like, I don't know. It goes somewhere and it kind of tapers off like this. Even with that, if you're looking at old data, you're going to have this very long run, right? You're going to have this very long run of data where most of the stuff is. New information is not going to change it very much because we have this huge backlog that any, particular interval going forward is not going to have that much weight against all this data unless you have a very steep data decay rate. So what can often happen is, I'll write it down here and I'll get rid of it. Popular products may often get recommended, but those recommendations lead customers to buy them, right? Because they get basically the prime recommendation spot, which tends to stabilize their sales, even if another product might potentially do better, right? The problem is, by the very act of recommending something, you're going to tend to boost its sales. So if you just go on the basis of, hey, there's some things that we've seen lately, they've been selling reasonably well, we're going to put them in the recommendations. If you never give other products a chance, then you're never going to know. You're going to never know if there's a better option. And so, yeah, if all you're going with is the data that you have, you're never going to be able to gather new data about new possibilities. All right, let's get rid of that. Boom. Okay, and last thing, purchase filtering. Okay, so for some customers and products, it makes sense to not duplicate previous purchases, right? So if you know a customer has bought something, in many cases you can be fairly confident they're not going to buy something again. In others, you should recommend. Okay, so a product that maybe you wouldn't buy more than one of, typically, for example, a particular book. If you bought one, you're probably not going to be in the market for a second one. So in many cases, it's going to make sense that that's not something you recommend if you know that the customer's already bought it. But B, something that people buy repeatedly, like say diapers, right? You ought to keep recommending that. Because keep recommending them, because a person that has, family that has a baby, they're going to buy diapers. They're going to buy a box of diapers every week for the next few years. So yeah, keep recommending those. Okay. So those are just some of the issues. Now again, like Facebook, when we talked about, do this in blue. Like Facebook, when we talked about design considerations there aren't always clear answers on what's best, right? In a new system, and Amazon in 1995, this is a very new system, there's inevitably going to be a certain amount of trial and error, just like for Facebook, okay? So you try some stuff, right? You go in with a good guess, but it's still going to be a guess because nobody's done this before, so you don't really know. Go in with a good guess, track how well it works, tweak it, and see how that works, and then update the model. Repeat as necessary. Okay, so that's what these systems do. They get some people together, they have basically a little bit of a brainstorming session talking about what makes sense. They build their model, they see how it works over time, they give it a little time to gather data, and then they say, well, what's some stuff here that doesn't make sense? Let's look at that. And then you make some tweaks to your model. You see how that works. You keep updating it, and you keep updating it, as long as you keep the model pretty much, because some of these things are always going to change, and some possibilities that might not have been technically or technically feasible or cost effective in 1995, maybe by 2020, it's no problem. So that's basically what we're dealing with. Now, all this that we're talking about goes under the header of what's called business process reengineering, or BPR. So BPR basically just means you have a process, you're changing it to something new. And typically that's going to be done as either a response to new technology. So there's some new technology that's available that makes some possibilities feasible that recently hadn't been. Or maybe you're doing it to keep up with your competitors. Or maybe you're doing it because you have a change in internal resources, right? For example, maybe your business just acquired another firm or merged with another firm that has very specialized knowledge, and you're going to be able to do some stuff that you didn't used to be able to do. Now, in most cases, BPR is going to be incremental, right? You're going to have a process already in place, and you're not going to change it all that much. So where it starts with first is mapping the process. Now, of course, the process should already be mapped in the sense that people should know the sequence of steps, how it's supposed to work. But at any rate, you map out the process, and then the need for business process reengineering is that there's something that you want to make better. So you identify problem points, things that aren't as good as they could be. Then brainstorm improvement techniques. A bunch of people get together from different parts of the business and they say, what could we do to help solve this problem? For example, the case of Amazon, right, circa 1994, somebody noticed, hey, even though we have so many titles, there's a lot of customers that are coming to our site and looking around for a bit and getting baffled and wandering away. Probably some of those customers left verbal feedback that said, wow, you have a great selection, but I'm so confused. I don't want to search through, a million different titles to find something that I'm looking for. So they identify this as a problem, right? A fairly high number of people visiting the website and wandering away without buying anything. So they brainstorm some improvement techniques. They talk, well, yeah, a recommender system, but how are we going to implement that? What are we going to do? What is a recommender system even going to look like for this, for our business? So they come up with some ideas, and at some point they have to throw one against the wall and see if it sticks. So they're going to have this idea, they're going to test it, they're going to implement it, they're going to give it a little time to run, they're going to evaluate how it works, and then go back and revise it. And it's, again, a circular process that never really ends. Okay, that's the incremental BPR process. However, sometimes the process reengineering isn't incremental. It's actually quite revolutionary. It really changes how the business does business. So, for example, what changed with Amazon's introduction of its recommender system? Well, first of all, the user interface changed, right? The website that people saw changed. Now, let me give you a little bit of information on how a website works. So, basic idea. There's a server. Whoop, I need a rectangle. There's a server. And on the server, there's a stack of web pages, right? So I'm just going to draw those as, kind of a little stack. We'll make this work. Okay. So on the server, there are a bunch of pages stored. Okay. When a customer visits the site, boom, boom, the server delivers a web page back. Okay, so customer goes there, picks a page, and the website delivers a page back to the customer. Okay, let's say the web server delivers the requested page. Okay, now if all these pages are static, as they typically were in 1994, okay, Amazon can just load them up to the server and more or less forget about them. Okay, so they're up there on the server. Amazon doesn't have that much to do. They exist on the server. Customer visits the site. Amazon delivers the content. Okay, but what happens if the pages are not static? If the pages have dynamic content, like new recommendations throughout the day, suddenly there's a whole big database access problem to manage. right? Basically, these servers are seeing a lot more internal traffic. And you have to design your systems to run with that, because you don't want customers coming to your website and trying to access a page on the server and having the wheels spin around for a while and then says, sorry, this content is not available right now, please try again. If customers see that often enough, they're just not coming back. Okay, so the fact that Amazon is putting these real-time recommendations up on their pages, even if they're just doing them in batches at the end of the day, if Amazon has many millions of products, this is a big deal, right? If you've ever seen how long it takes to, copy a large batch of data, even on one of our machines, right? Think about how much longer it would have been 25 years ago. All this stuff takes a long time. So they had to build new and different systems that could handle this sort of traffic. Okay. So that's one thing. Just the fact that they're injecting this content into the web pages, the user interface is going to change. Amazon's going to have to figure out a new layout for how the web page is going to look. Where are they going to put these links for the recommender system? The data requirements. Amazon is suddenly in the it's one thing to say, let's do this. Amazon has a large pile of purchase data. Okay. And Amazon has another large pile of page view data. But then Amazon has to combine all of those, right, into some monster data set of combined data. Okay, all this stuff together, these combinations are going to be bigger than either, because for every purchase, for every page view, right, there will be a list of, I'm going to scrunch that down a bit, of promising items. Okay, for every product, there's going to be a list of promising items. And there will be rankings. There will be updates. All right, there will be data decay. So you have to keep track of what data is older, things like that. All these kind of factors that are coming in, you're going to get a very, very large set of combined data, much larger than just the list of who bought what and who looked at what web pages, right? The combination of those two is going to be much bigger for every product, not products. Okay. There will be data decay. All right, so you get the idea. So suddenly there's a lot more data to measure and to store and to process just because Amazon's doing more with it, right? So the other thing, storage isn't really the problem, okay? Data storage capacity is cheap, right? We talked about this for Facebook. So, I don't know off the top of my head exactly what it was in 1995, but again, roughly speaking, RAM costs 100 to 1,000 times as much as hard drives. Okay, so storage capacity is going to be pretty cheap. Okay, the RAM is the issue, but the ability to quickly process the important data, that's where the big expenses come into play, because you can't do that just with hard drives. Okay, you need a whole bunch of systems that are just constantly reading from the machines and crunching it and keeping it up to date. Yeah, that's what the problem is. So the ability to process the data quickly, and all that will probably need custom software and custom systems, right? Amazon was actually building, potentially including custom hardware. Amazon actually was doing this because nobody else could keep up with what Amazon needed, so they ended up having to do some of their own work. Okay. So data requirements are large, data management is going to be large, impact on other systems, okay? We talked about this too. So probable consequences of a successful recommender system implementation, okay? Number one, more sales. Number two, more visits, right? Customers come back. Number three, more growth. Well, what's that going to mean? Any systems that are bumping up against their capacity limits are really going to be in trouble. Okay? So for example, that could be internal analytics, right? All the stuff you're trying to track about the website, if suddenly your sales growth rate doubles, all right, and you're just getting more traffic generally from the number of visitors you get, boom, that's going to mean there's a lot more internal analytics to manage. Number two, transaction processing, okay? Any of that stuff, if you were starting to bump up against the limits of your ability to process transactions, right? Maybe every now and then you get like 100 transactions per second, which was huge in the 90s, right? That could be catastrophic if they fail to keep up with that. What else? Shipping and order fulfillment generally, right? If they don't have enough employees, what are they going to do? Imagine that all of these can be multiplied during the busy season, right? So obvious ones like Christmas or other big holidays, okay? Eventually, Amazon Prime Day, which they didn't have back then, but if they did, yeah, that would be something, okay? So whenever things get busy, it's even going to be worse. So any systems that are starting to experience capacity problems that can't process everything that they need to quickly enough, yeah, they have to manage for that. Okay. So I have a couple articles here if you want to go back and look. Amazon's recommender system development. Pop this one up briefly. Let's see how it goes. This is, I believe it's from Harvard Business. Oh no, IEEE, Internet Computing. Even though it's sort of a research article, it's a pretty intuitive way to describe how the algorithm works for generating recommendations, right? So you don't have to be a math expert to understand what's going on there. Essentially what happens, if you want to identify, suppose you want to identify which products are similar, okay? Basically what they do at the math of it, here's your base product. And suppose you have a couple of options, right? Option number one, and another option we'll call option number two. I'm going to thread that between those two. Okay. So what they do, whoops. Amazon converts the sales and page view data into a vector, right? Basically, in this case, a line. Basically, a series of data points that intersect with the base product. If the products are very similar, the two lines will be almost collinear, right? They'll almost totally overlap with each other. If they are very dissimilar, they will be almost perpendicular, right? They'll be at 90-degree angles. So an extremely, different product. It would be like people who bought this almost never bought that. Might look something like that, right? So I'm going to thread through so it is pretty much perpendicular through that point. Okay, so I'll mark here, very dissimilar product. Okay, and that's just the math of what's going on. This isn't a math course, this isn't a data mining course, but that's just the fundamental intuition about how the recommendations are generated. You build a line that describes one of the product sales and you use the same line building model to describe other product sales. Whichever ones are most comparable, right, most similar, then those are the ones that are going to show up in the recommendations. Okay. I don't know why that happened. We lost something here. That's weird. Okay. So recommender system. Now, speed versus integration. So very often getting something designed quickly is going to be a high priority when you're designing a new system, when you're trying to implement it, right? You know that you have a limited time to finish it before your competitors will come up with something similar. So you want to get it done first and do a decent job of it. Now, what might be surprising is that it's often easier and faster to build an entirely separate system than to integrate it into an existing system. In that case, you have systems that operate as modules, right? They're separate from each other, and it makes it easier to control who has access to what systems in terms of data integrity, in terms of security. You can say to some people, this is your system, only you guys are able to work on it. But if your systems aren't integrated, in the long term, that's going to create some serious issues, right? So for one, if you have the same data stored in multiple databases, they can conflict. For example, if you have if you have information about two of your business partners, their phone number has changed, their access person has changed, one of the databases has the current updated one, the other one doesn't, right? That can be a problem. So you're not necessarily going to get correct information when one system needs to find out something, even though that information is available in your organization. Number two, as your databases get big, it gets very difficult to cross-check data for accuracy, right? So in order to find what's where, essentially for every record in one database, you have to comb through the other database, find that record, and verify that its values match with the other one. So we have there some O notation for just the order of the effort involved. So O squared means essentially we're multiplying the two tables by each other. If the tables are very large, then that represents a tremendous workload. And last, there's potentially a very large latency in queries across databases. Basically, it takes a long time. So for example, back in the day, right, back in the 90s, if you wanted to get a business loan for some purchase, imagine if you were a retail store and you wanted to order a load of like 1,000 bicycles ahead of the Christmas season, and you wanted to see if you had enough credit and how long it would take, stuff like that. You called up the manufacturer and you said, hey, I want to order this and this and this and this. It would take them a few days to get back to you to figure out what the terms were going to be, to figure out how much it was going to cost, to see if they could even fulfill that order, because the data was stored in different databases and access was basically manual. So you had to call up, Joe in finance or Fred in accounting to find out what the situation was. Okay, but as you know, it's not really like that anymore, as perhaps you know. We'll talk about that in a little bit. But for now, we're going to talk about data silos. So data silos means you have different functional areas or other work groups that have separate database systems. Now, this is very common for paper-based systems. And if you still had any of those today, it would still be pretty common. But, the state of things in the 80s and 90s, this was quite common. And the reason was, it's kind of a pain to make updated copies of everything when everything's on paper. Also, business units that operate separately but under the same ownership umbrella. For example, if there's been a merger and acquisition, for a while they're going to tend to keep their own database systems. Now, these days, eventually the data will tend to get merged together into one, but for a while, yeah, they're going to keep using the data they already have. Other things, global operations. We'll have an example for that in just a moment. So, The problem with data silos is that the answers are there, but if you're doing enterprise-wide analytics, getting those answers is going to be complicated and slow. One problem is queries may require multiple database permissions, and you'll have to actually talk to people at the various parts of the organization who are the gatekeepers to their department's databases. So you won't be able to get those answers super fast. You'll have to talk to somebody, verify who you are, get access that way. They'll run the query for you. The other thing is these database systems will generally not be optimized for operations across databases. So they may be optimized for whatever goes on within one particular department, but as far as the organization as a whole, yeah, it could take a while. Okay, so we have an example here. If all that seems a little bit fuzzy, we're going to try to make that a little bit clear. So this was actually an example. I forget who it was when I first put it together, but I believe it was Royal Dutch Shell. And they're a big global oil drilling operation. Okay, so they're a global oil drilling operation, and they have operations in many different countries. They've acquired many local drilling operations in a variety of different languages and units with their own separate databases. Okay, so they have a huge data repository, but they have local code variations for things like mineral types, for assay results. That's where they dig into the ground and see what kind of minerals are there so they can estimate the probability that oil will be there and how much. Different code variations for drilling equipment, and the different databases used by those local operations often even use different data fields. So what's the problem with this? Well, number one, the system works well to answer local questions, right? Like if you want to say, how much oil can I get from a particular drilling operation? Sure, you can run that query, right? But global problems are going to be a lot more difficult. So let me give a specific example. Okay, so we're going to draw two tables here. Okay, so table one, let's say that is for an operation, I don't know, in Indonesia. Okay, and table two is going to be off of Norway. Fine. These are the two big drilling operations they're looking to compare. So what data fields do they have here, right? So they have the machinery that's in place, right? The drilling equipment. They have the currency that's in place, local currency. Let's add that. It's all in metric, so that's not such a big problem. Metric, we'll list that. Mineral types, right? Again, in the local language, because this was an Indonesian operation. Okay, same thing for Norway. All right, they have their same stuff. They have their drilling equipment using local codes. Okay, again, the value of the oil or everything else is in local currency units. Those can change over time. Still using metric systems, so that's okay. And then mineral types. Number one, a different set of minerals. And number two, based in local language. Okay, I'll make a note for that. So if you were going to try to write a SQL query around this, right, you could write to pull the desired results from table one. And you could write a second SQL query to pull the desired results from table two. But because the two tables are using different fields, number one, results may not be comparable across tables, right? So for example, if the table two has a different set of minerals, they might have information that table one doesn't. They might be able to make more accurate predictions. Or maybe table one has information that table two doesn't. Same thing, right? So the results may not be comparable. And number two, right? What's the other problem? Okay, even if the results are comparable, you would still need to write separate queries for both tables in any event. Okay, so imagine if you have literally dozens of different drilling operations like this. Yeah, very easy. So results, consequently, very easy to generate a ranked list of best drilling options for a particular location. Very painful to generate a ranked list of best drilling options worldwide, right? Or any other kind of global query. Okay, your system's going to be great for answering these local queries, going to be very slow and painful. You have to write custom SQL queries. You have to then get the results, make sure that they're comparable, which they might not be. It's a big headache. Okay, so this was the problem they actually had. So let's go one more. So obviously it sounds nice. Well, why does that even happen, right? Why wouldn't you make all of your databases be integrated from the start? Why do data silos even happen? Well, number one, for small businesses, silos are pretty much just a theoretical problem, right? If you're a small business, your operation is just going to exist in one location, so the idea of these global concerns don't really come up. If you're a very small operation, you may have a single employee managing multiple silos, right? You may have one guy doing the finance and accounting. You may have one guy in charge of the operations and the marketing. So there's not really a silo as such. And even if there is, when you're a small business, the volume of data is pretty small anyway, right? Just like the early days of Amazon, you could get by with a single copy of Microsoft Access or Microsoft Excel. But the problems happen when the business grows. As the business grows, especially if it gets into multiple locations, certainly if it hires many more people and starts dealing with a lot more data, then suddenly what used to be manageable by a small set of people, and if you had questions, you could just lean your chair out into the hallway and say, hey, Joe, what's the answer to this, right? But the business gets big, you can't do that anymore. So eventually, if a business gets big, it starts to realize, hey, we have this problem with data silos. We need to solve this by integrating all of our data into a common structure and system. So when that becomes necessary, they're going to do that. They're going to integrate their data into a common system. Specifically, the tables will be structured the same way with the same fields and same formats. And this is known as enterprise resource planning. So ERP is a system that does exactly this sort of thing. If there's a large business that has many different data silos, you want to take all that data, integrate it all into one common system so that there's only one answer in one place. All right, I'll mark that down in the slides here. And we'll talk a little bit about ERP later on. Solution, enterprise resource planning, or ERP, which ensures there is one answer to any question and all the data is kept in a common format. Okay, so it solves the problem of these kind of data silos. Okay. And this is a good point to break for the day. I have data mining. I can come back and talk about that on Thursday. And then we'll also do the follow-up lecture, the last of the 3 Amazon lectures. But this is a good break point. So we can leave data mining for another day. So I'm going to ask, anybody have any questions on this stuff? I'm going to stop the recording.